Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Illustrative Maths Unit 3 on Similarity, Lesson 6, Connecting Similarity and Transformations. The learning goal in this lesson is to identify similar figures. We have two learning targets in this lesson. Number 1 says I can write similarity statements. Learning target number 2 says I know the definition of similarity. We have one glossary term for this lesson, and that is similar. One figure is similar to another if there is a sequence of rigid motions and dilations that takes the first figure on to the second. Triangle A prime, B prime, C prime, which is the green triangle, is similar to triangle ABC because a rotation with center B followed by a dilation with center P takes ABC to A prime, B prime, C prime. So what they're saying there is if we take the original blue triangle ABC and we rotate it clockwise with B as the center, then we will create the red triangle. Then by dilating, we can turn the red triangle into the green triangle, which means the original blue triangle is similar to the green triangle. I want to stress the difference between what we're talking about now, which is similar, versus what we talked about before, which was congruence. Remember, we said that two shapes were congruent if you could take the first one to the second one by using rigid transformations. The difference with similarity is that we're now allowed to use dilations as well. So we can use rigid transformations, but we need to dilate them because they're going to be bigger or smaller. So this goes back to what we were talking about before, where the size of the side lengths might be bigger or smaller, but the angles are the same. This is because of that small difference between similarity, which says we can dilate, we can make it bigger or smaller, versus what we had talked about previously, which was congruence, where you were not allowed to change the size at all, so you were only allowed to use rigid transformations then. Now that we're done with the introduction, let's take a look at practice problem number 1.
We're going to solve this problem not because it's easy, but because we need to get to Mars.
Practice problem number 1. Find a sequence of rigid motions and dilations that takes square ABCD to square EFGH. So remember that the letters are in order and that they should match each other in order. So when we say that we want to take square ABCD, which is this large green square, and we want to take it to square EFGH, which is this smaller blue square, we want to do so that side AB matches side EF. So I need this side right here that is labeled with a length of 5 to be laying on top of this side here, EF, that is labeled with a side length of 2. So the first thing I'm going to do is I'm going to move along directed line segment AE. So translate square ABCD along directed line segment AE. And what that is going to do is it's going to produce this square right here. So point A is now point E, and this is point B prime, C prime, D prime. Now the second thing I want to do is I want to rotate side EB counterclockwise until it's laying on top of line EF. So rotate square E, B prime, C prime, D prime counterclockwise to line segment EF. And that ends up creating a square like this. And we still have point E here, but now B prime has become B double prime. This is C double prime and D double prime. And now the last thing we would need to do is to dilate. So dilate square E, B double prime, C double prime, D double prime by, remember, we always want to use new size over old size. So in this case, the new size is 2 and the old size is 5. And so if we multiply every side of the big square by 2/5, it will create this square that lies directly on top of EFGH. And that's what they wanted us to do. So if you still have any questions about this practice problem, please leave a comment below.
Now, some might say this problem is too difficult. They'll tell you to give up, but I believe in American ingenuity. I believe in your ability to find a solution. Let's get to work.
Practice problem number 2. Quadrilaterals Q and P are similar. Notice they said similar, not congruent, because they're the same shape, but they're not the same size. Number 1, what is the scale factor of the dilation that takes P to Q? So you can pick either side that you know the numbers of. We have 4 and 5 on the top. We have 2 and 2.5 on the bottom. I would prefer to do this with whole numbers, so I'm going to be using these top sides here. Now, number 1 wants us to go from P to Q, and number 2 wants us to go in reverse from Q to P. Now, in either direction, it's a very simple process as long as you remember one thing. Your dilation scale factor is always your new size divided by your old size. So when we look at number 1, we're going from P to Q. So my new size, if I go from P to Q, is 5. My old size would be P, which is 4. So to go from P to Q, I would multiply by 5/4. Now number 2 has us going the opposite direction. So now if I'm going from Q to P, P is my new size, so that's 4, and Q is my old size, which is 5. So my scale factor to go from Q to P is 4/5. Now we could double check these just to be sure. If I'm going from P to Q, then I have 4, which is 4/1, times this scale factor of 5/4. These 4's would cancel each other out, so I would have 5/1, which is 5. And that's exactly what I see right here. I could even do it with the other one. Down at the bottom, I had 2, which is 2/1. If I multiply that by 5/4, then 2 goes into 2 one time. It goes into 4 2 times. So I get 5/2, which is 2.5. And that's exactly what I see right here. Let's check it in the opposite direction. If I was going from 5, then that's 5 over 1. I multiply that by 4/5. 5 goes into 5 once. 5 goes into 5 once. And I get 4 over 1, which is 4. And that's exactly what I get. Now to try it in the opposite direction, I have 2.5. I multiply that by 4 over 5. 2.5 goes into 2.5 once. 2.5 goes into 5 twice. I end up with 4 halves, which is 2, and that's exactly what I find here. So you can always check yourself and make sure that your scale factor works, but it's very simple. Pick two sides that are similar, and it is going to be the new size divided by the old size. And this allows you to go in both directions. If you still have any questions about this practice problem, please leave a comment below.
You kids have it easy. Back in my day, we didn't have calculators. We had to use our noggins.
Practice problem number 3. What is our definition of similarity? So the important thing here is that we want the definition. So A says if two figures have the same angles, then they are similar. Well, this is true, but it's not the definition. This is more what you would call a characteristic or a trait of similar figures. If you have two similar figures, then yes, their angles are going to be the same, but that's not the whole definition. B says if two figures have proportional side lengths, then they are similar. Once again, this is a true feature of similar figures, but it's not the definition. Choice C, if there is a sequence of rigid transformations taking one figure to another, then they are similar. The problem here is that this is not the definition of similar. This is the definition of congruent. Because remember, congruent figures are the exact same size. So you can go from one to the other just through a sequence of rigid transformations. The full definition of similarity is choice D. There is a sequence of rigid transformations and dilations, because similar shapes can be different sizes. So not only do you need to be able to move one over to the other through the series of rigid transformations, but then you might also need to dilate in order to make it bigger or smaller to fit on the similar figure. So yes, they're going to have the same angles. Yes, they're going to have proportional side lengths, but the official definition is that there is a sequence of rigid transformations and dilations that take one figure to the other. That is the definition, and that is the difference between congruent and similar. I hope this helps you get a better understanding of these three practice problems. If you do still have any questions, please leave a comment below. So we had 2 learning targets here in Lesson 6. Number 1 says I can write similarity statements. So we walked through some of the steps, like we talked about translating along directed line segments. We talked about rotating a figure so that you could line up the correct sides with each other. And we talked about how to figure out the scale factor for your dilation. And that way we can write these similarity statements where we can explain what the steps are to put one figure onto the similar figure by going through those rigid transformations and dilations. And that leads into learning target number 2, which is that you know the definition of similarity, simply meaning you understand that it is a series of rigid transformations and dilations. If you can do those 2 things to make one figure lay on top of the other figure, then those figures are similar. Some of the features are that they will have the same angles and they'll have proportional side lengths. But the important definition is that there's a series of rigid transformations and dilations. That's what sets it apart from congruence, because with congruent, there's no dilations. They're the same size, so you can just move one to the other through rigid transformation. With similarity, you've got to do that dilation part because now they might not be the same size. I hope this helps you understand Lesson 6. If you do still have any questions, please feel free to leave a comment below. If you found this video helpful, please give it a thumbs up. If you would like to see more, then in the bottom left of the screen, you should see another video that YouTube is recommending. And in the bottom right of the screen, you should see the subscribe button. It really helps the channel out when you subscribe. I look forward to seeing you in the next lesson.